All right, so getting into our last part of statistics with Chapter 10. Chapter 10 will be broken up into two lessons. So you get in the first half today, and the first half is a little more introductory. The second half that we're going to do in the next video is all the calculator stuff. And so make sure that you watch that next video. That one's going to be really important. This is mostly introduction. There's some good ideas in here that you do need to get out of this, but this is a lot of just kind of some background knowledge and some things that will help as we get into the main lesson on this, which is going to be the next video. So what you're going to see in these two videos is the topic on bivariate data. All that simply means is you now have two variables instead of one. So we are now comparing two things. So if you see in the one that we're going to do here in a minute, we are comparing length of something to the weight of something. So typically on something like that, what would you expect? Would you expect that the longer something is, the heavier it would be? The longer something is, the lighter it would be, so on and so on. And so keep that in mind, but that's the main idea for this unit, is that we're going to be comparing two variables. So we now have an x variable and a y variable. So we now have that bivariate data. And for the most part, what we are checking to see is, are they related to each other? Is there a correlation between the x values and the y values? The most common graph that you would see for bivariate data, so something for two variables, is a scatter plot. Simply because when you have two variables, it's like having an x-y coordinate, and so we're just plotting x-y coordinates on a graph to create our scatter plot. And I know you guys have seen scatter plots before. This is also an older concept that we get in early algebra, is to do scatter plots. So when it comes to making a scatter plot, so we have the x coordinates identified up here, we got the y coordinates down here. Typically this would be done on IB graph paper, so if you're going to do something like this on an IB test, which you most likely will, for those of you who are going to take the IB exam, this is a really popular area and you're sure to be tested on this. So as we make our scatter plot, come back to that in a minute. Remember, this typically is done on IB graph paper, and they will give you some type of a scale by centimeters. So remember, every fifth line, like this one, is a little bolder. So that's the first fifth line. Here's the next fifth line. Here's the next one. They refer to those lines as centimeters. So this would be 1 centimeter, 2 centimeters, 3 centimeters. So they might say something like, on the x-axis, let 1 centimeter represent whatever. So 10 items, and so this would be 10, 20, 30. And they might say, let 1 centimeter on the y-axis represent 5 units. And so again, I'd be counting by 5, 10, 15. And again, when you do use this graph paper, you don't have to start in the corner. You don't have to make this 0, 0. You can create it anywhere on the page. You just have to make sure that if you're going to create, like, say, this line is your y-axis, and right here is going to be 0, 0, and this is my x-axis. So if I'm going to do that, I have to really make sure that I make these lines, my axes, super dark and label them. That's really important. IB grading, they grade you on labeling your axes. So you would have to label this as for whatever it stands for. So if it's length, like this problem is, then we got to label this as length, label this as weight, and then label what we are counting by for every centimeter. So we want to label what that line represents and what that line represents. So that's really important when you're doing scatter plots or anything on graph paper, that you label everything nice and clear to get all the points. So going back to this one, remember, as if we're talking about length and weight, you know, typically the longer something would be, the heavier it would be. And so we're going to see this positive relationship right here of increasing, simply because as length increases, most likely weight would increase. And so if they're both going to increase at the same time, you're going to get the positive relationship that you see here. The inverse of that would be, as one increases, the other one decreases. So let's just say we were going to compare the number of hours that you watch TV to your test scores. You know, you might argue, or we might see with data, that the more TV you watch, the lower your test scores would be. And so as one increases, the other one decreases, and that's going to give you a negative trend, something like this direction. So that's just however X and Y are going to relate to each other. Whenever we are asked to describe a scatter plot or what we find with a scatter plot, there's always two ways to describe it. And so you always got to make sure that you give it two names. The first one is positive or negative. So you got to say whether it's positive or negative. Even though we look at that and say obviously it's positive, you got to state that. That's part of the description that they're looking for whenever they ask you to describe the data from a scatter plot. So this one we would describe as positive. The second way you would describe it is not only linear, but how linear. So in this case, we can see that there does seem to be a linear trend to this, but we don't just say linear, and I'll explain that here in just a minute. But here's a few examples. Let me give you an even better one. Here's a good one. So on this one, you can see some ways that we would describe our data. So these three are clearly all positive, right? In this one, we would say these are more spread out, so we would say this is weak positive. These are a little closer together, so we'd say this is strong positive. And if they were in a perfect alignment, right, we would say it is perfect linear or positive and positive. And then here's the same descriptions, but in the negative direction. And so we always got to give it two names. So, right, what you're seeing down here below, as well as positive or negative. You always got to give it two names for these guys. If it is not linear, I'll show you these guys real quick. So take a look at those. So obviously this is linear. These are non-linear. So even though there's some relationship going on, if it's not linear, we really can't use it for bivariate data the way that we're going to use it. And so we'd say there's not a linear relationship to that. So here's a good example of no relationship at all. We cannot see whether this is trending positive or negative. Therefore, we'd have to simply say there is no correlation in this data. So when we describe it, again, you got to give it two names. And so this is the type of response that they are looking for. So this would be a strong negative. This would be a weak positive. So it's trending positive, but it's pretty well spread out. So it's weak positive. So again, two names on all that stuff. That's important. Once you make your scatter plot, there's a couple things we're going to be doing with it. And to be honest with you, what you're going to see in the notes here that we're going to be doing by hand are all things I'm going to show you how to do on your calculator in the second video that you'll see on the next one. So one of the things that we can come up with with these data points is what we call a line of best fit. So if you were to plot your data, so in this one you can see they're now comparing how old you are to how many hours you sleep. And so what we're going to see on this is basically, because it's negative, right, the idea is, well, that must mean that the more years I have, the less I sleep, or the older I get, the less I sleep. And there are going to be questions that ask you to interpret things like that. So make sure that you understand how to describe what we're finding with the relationship. So when they ask us to describe what's taking place within this data, because it's negative, because it's a negative correlation, I need to be able to interpret that for what's being tested. So that's where I would need to be able to recognize that what's going on here is the bigger my years get, the less my hours get. And so we got to be able to interpret those things. So a couple things we could do with this by hand that we're going to be doing on the calculator in the next video. If we're going to draw a trend line or a line of best fit, or what is also known as a regression line, one way to do that is by kind of eyeballing it. And that's what you're seeing in these notes is sort of an eyeball method of getting a line of best fit. The one point that we know for sure has to be on this line is what we call the mean point. So if I were to find the average of my x's and the average of my y's and create an ordered pair of those averages, that would be the mean point. And so that's what's going on right here. And if I was going to do this by eye, I'd have to make sure that my graph passes through that point. But other than that, the rest is kind of left up to interpretation. You simply want to draw the line If I'm doing this by an eyeball method, well, I would probably say, well, let's get an equal amount of points above and below this line. So you can see I have 1, 2, 3 points below the line, as well as 1, 2, 3 points above the line. And so that would help me guide a little bit where to draw the line. But you know, we all might draw this a little bit differently. Somebody else might kind of start here and draw their line through M, and it might do something like this, and that would still be an equal number of points on both sides. It would still go through the mean point, but somebody could get something a little different than what you might get. And so that's why the eyeball method is not a popular way of doing this, is because it creates room for a lot of different answers for doing something like this. So we'll be doing this line of best fit in our calculator in the next video lesson, but this is kind of the way you could do it by hand. Anyway, once we did that, we then pick a point on our line. So this is the chosen point that's on this line, and it does not have to be one of these points. It's just a point on our line. And so we picked a point on the line. So if I use this point and this point, I can use my slope formula, y minus y over x minus x, to get the slope. And I can go through the whole point slope process for getting the equation of this line. And that's what you're seeing for the rest of these notes, is using a point slope process to get an equation like this of that line. But like I said, the person next to you might have chosen a slightly different line, so their numbers are going to be a little different than yours. And so this is again left a little open for interpretation here. So, but watch this, because this part really matters for the next video lesson. So on this one thing that we do with this equation once we have it is use it to interpret other values. So if I have the line going through these data points, I can now use it to make estimates of results. So now if I were to say something, well, you know, what if I had the point of about 0.75, what y value do I expect to go with that? Or if I have 7.5 years, how much sleep do I expect to get? And so I would say, well, here's 7.5 years, therefore this is how much sleep I think I would get. And so we can now use our information to estimate other data values that we'd want to come up with. So again, if I wanted to say, well, if I am 6 months old, I can now plug 6 months or half a year into my equation and estimate how many hours of sleep I would get if I was 6 months old. And so that's really what this equation is used for, is to estimate other values. Big idea with this: if I am using a data point like 0.5, so look at my line here for a minute, you'll notice that 0.5 is within the range of my data. So if my lowest point was at 0.1 and my highest point is at 1 point whatever, then 0.5 is certainly in between those data values, so we call this interpolation. So if I am subbing in a number that is within the range of my data, then we call that interpolation. If you were to sub in a value that is outside your range of data, so what if I said 5 years old, right? That's way outside the range of my data. Look up here. So this only went up to 1.1. So if I said, well, how much sleep would I get when I'm 5 years old, we call that extrapolation, because it is outside the range of my data. And the big idea on that is it's only considered an appropriate use of your equation if it's interpolation. So when we sub in a 0.5, that is clearly within the range of my data, so we would say, yeah, that's an acceptable estimation. If it's extrapolation, then you would say it is not an acceptable interpretation of the data, because it's extrapolation. So whenever you're asked that question, you have to give a reason for it. And so you're either going to say, yes, it's acceptable because it's within the range of my data, or you would say, no, it's not acceptable because it's outside the range of my data. And so those are one of those two ways is how you would always answer that question.